This is video 4 for chapter 12 on dilution. And dilution is a pretty simple process. Essentially what you're doing is you are taking a more concentrated solution and you're going to dilute it by adding water to make something that is less concentrated. So if you were to have, like when I make preparations for your lab, the acid that I buy from our supplier is 12 molar HCl. And that's too concentrated to give you guys. So I dilute it with water to make it, say, 6 molar or 1 molar or 0.1 molar, depending on what the lab is that you're doing and what it requires. But there's a really easy formula to follow to do this. And it's basically that we are going to use the molarity of, so capital M, remember, is molarity, the molarity of the concentrated species times its volume. And then what that's going to equal the molarity of the dilute species times its volume. And you might remember that molarity times volume is always going to give you moles. So basically what we're doing is keeping the moles the same, and we're just changing our volumes. Now, as long as you know 3 out of the 4 variables, you can solve for the 4th. So the problems themselves are not difficult. The most important thing to do is to keep the information paired together the right way. So if you look at the practice problem that's on your sheet, it says what volume of 7.5 molar Na2SO4 solution is needed to produce 125 milliliters of a 0.45 molar solution. Now looking at the two molarities, the bigger number is the one that is more concentrated. So our molarity of our concentrated solution is 7.5 molar. The molarity of our diluted solution is 0.45 molar. Now, what we want to know, if we pair this up properly, we want to know what volume of the concentrated solution we can get. So we're going to look at what we need. So volume of our concentrated solution is our question mark. And we know that we're using 125 milliliters of the dilute solution. So the biggest challenge you have, at least initially, is just getting the information paired the right way. Which one goes with the concentrated, which one's going with the dilute. Now, if you use your formula the proper way, so we know that molarity of the concentrated times the volume of the concentrated is equal to the molarity of the dilute times the volume of the dilute. And what we're looking for here is the volume of the concentrated. So to solve for that, I'm going to divide both sides by the molarity of the concentrated substance. And so when you do that, this will disappear, reduces to 1. So now I'm just going to plug the numbers in that I have. My molarity of my dilute solution is 0.45 molar times the dilute volume, which is 125 milliliters. And then I'm dividing all of that by the molarity of my concentrated solution, which is 7.5 molar. Now, label-wise, you can see that molarity is canceling, and our answer should be in milliliters. And if you do your math properly, you actually get 7.5 milliliters. And that's what I want the volume of the concentrated to be. So I'm going to use 7.5 milliliters of concentrated Na2SO4 in this case. But I want to make 125 milliliters of the solution. So the rest of it, which is going to be 117.5 milliliters, would have to be water. Now, you don't have to have this portion of the answer to get correct. I just want to make sure you understand. The answer that we're looking for is 7.5 milliliters of the concentrated stuff. But I'm going to add to it some water to get to that total volume of the dilute, which was 125. So hopefully you understand how dilution works, and we can practice more with that tomorrow in class.